Let's turn, though, to a fascinating story because scientists have discovered a gigantic ring-shaped structure in space which is so big it challenges our understanding of the universe. Experts at the University of Central Lancashire say it's 1.3 billion light-years in diameter.
As we progress further into 2024, the rate of discovery of new scientific information continues to excite and get the attention of scientists as well as the general public. These discoveries extend to cosmic explorations of the universe and shocking advancements in technology, allowing researchers to uncover findings that increase our insight into the universe while offering innovative solutions to deal with environmental challenges. These unique scientific discoveries of 2024 have reshaped our view of the world and beyond. From unraveling the mysteries of the universe to pioneering new technologies, scientists have made tremendous strides, opening doors to new possibilities and raising fresh questions. In this video, we'll delve into 5 of the most significant scientific discoveries of 2024, exploring their implications and the potential impact on our future. So don't go away, stay with us and keep watching our channel, and also subscribe our channel. 1. The Big Ring. A massive cosmic structure known as the Big Ring has been found, defying our current understanding of the universe. This nearly perfect ring of galaxies spans 1.3 billion light-years across, and its light took 6.9 billion years to reach us. Its colossal size and unusual shape suggest it doesn't align with known cosmic structures, challenging the standard model of cosmology. Astronomer Alexia Lopez identified the Big Ring, which follows her team's 2021 discovery of the Giant Arc, another vast structure nearby. Neither structure fits conventional models of galaxy formations, leaving researchers puzzled. They aren't baryon acoustic oscillations, which are fixed at around 1 billion light-years. Some theorists speculate that these formations may hint at cosmic strings or even topological defects in spacetime. The mysteries of the Big Ring and Giant Arc may reveal hidden aspects of the universe's evolution. In detail. The giant structures are not only about the same age, but also only around 12 degrees apart. This raises the question of whether the cosmic neighbors were once part of a single, even larger association. An exciting question, but one that is unlikely to find an answer anytime soon. After all, astronomers have so far only been able to speculate about the background to their formation and the exact nature of the structures. One theory is that the Big Ring could be related to baryonic acoustic oscillation. These arise from oscillations in the early universe, and today should appear, statistically at least, as spherical shells in the arrangement of galaxies. However, detailed analysis revealed that the Big Ring is too large and is not spherical. Cosmological theory suggests that the largest structures in the form of chains of galaxies and galaxy clusters that BAOs could form should be, at most, 1.2 billion light-years in length. Yet, the circumference of the Big Ring and the length of the Giant Arc dwarf this constraint. To put into context how immense these superstructures are, the Giant Arc is 1/15 the radius of the whole visible universe. One possibility is that the structures are hinting at exotic forms of currently known physics, or perhaps even new physics. For example, the Nobel laureate Sir Roger Penrose, who is a professor emeritus at the University of Oxford, has suggested a model called conformal cyclic cosmology to describe a cyclical universe. Per this model, evidence for gravitational waves from previous eons of the universe could manifest as giant ring-shaped structures in the CMB. There are other huge superstructures in the universe too, such as the Sloan Great Wall, which is 1.37 billion light-years across and about 1 billion light-years away from us. The South Pole Wall of Galaxies is a more recently discovered structure. It's 1.4 billion light-years in length. The Big Ring stands as one of the most intriguing cosmic puzzles of our time, challenging foundational principles and inviting astronomers to look beyond established models. Its discovery, along with the Giant Arc, suggests that the universe may hold far more surprises than we imagined. 2. Tiny robot. Washington State University has developed the smallest, lightest, and fastest fully functional micro-robots known to be created. The 2 miniature insect-like robots could someday be used for work in areas like artificial pollination, search and rescue, environmental monitoring, or robotic-assisted surgery. The mini-bug robot weighs just 8 milligrams, while the water strider robot weighs 55 milligrams. Both move at about 6 millimeters a second. The key to these tiny robots came from tiny actuators, created with a fabrication technique miniaturizing the actuator down to less than a milligram, the smallest ever known to have been made. The researchers aim to copy another insect and develop a water strider-type robot capable of moving both across and beneath the water surface. They're also working on new power supply options to make their robots fully autonomous. The essence of these miniature robots lies in their small actuators, which drive their movement. Trigstad implemented a novel manufacturing technique to reduce the size of the actuator to less than 1 milligram, making it the smallest ever created. By repeating this heating and cooling process, displacement energy is created that is used for locomotion and other mechanisms of the robot. These beams also use a shape memory alloy that remembers the shape it was before and will always return to the same shape as it is heated and cooled. Unlike typical motors that move robots, this process does not use any moving parts or spinning components. Two shape memory alloy wires 1/1000th of an inch in diameter can create enough energy to allow robots to flap their fins or move their feet at up to 40 times per second or lift more than 150 times their own body weight. The main limitation of the current technology is that the two robots are required to be connected to an external power source. The WSU researchers' next steps are to use tiny batteries or catalytic combustion to allow their robots to be untethered from a power supply. 3-dot water batteries. Water and electronics don't usually mix, but as it turns out, batteries could benefit from some H2O dot. By replacing the hazardous chemical electrolytes used in commercial batteries with water, scientists have developed a recyclable water battery and solved key issues with the emerging technology, which could be a safer and greener alternative.
The next step of water battery is to further increase the energy density of the water battery by developing new nanomaterials as the electrode materials.
Water batteries are formally known as aqueous metal ion batteries. These devices use metals such as magnesium or zinc, which are cheaper to assemble and less toxic than the materials currently used in other kinds of batteries. Batteries store energy by creating a flow of electrons that move from the positive end of the battery, the cathode, to the negative end, the anode. They expend energy when electrons flow the opposite way. The fluid in the battery is there to shuttle electrons back and forth between both ends. In a water battery, the electrolytic fluid is water with a few added salts, instead of something like sulfuric acid or lithium salt. Crucially, the team behind this latest advancement came up with a way to prevent these water batteries from short-circuiting. This happens when tiny spiky metallic growths called dendrites form on the metal anode inside a battery, busting through battery compartments. Although the new technology is unlikely to replace lithium-ion batteries anytime soon, with further research and development, water batteries could provide a safe alternative to lithium-ion ones in a decade or so. Lithium-ion batteries, which are found in everything from laptops and phones to electric bikes and cars, can overheat and catch on fire in extreme cases. This is because lithium is quite an active metal, which is submerged in an organic electrolyte. A major hurdle to using aqueous metal ion batteries has been dendrite growth. To inhibit this, the researchers coated the zinc anode of the battery with bismuth metal, which oxidizes to form rust. This creates a protective layer that stops dendrites from forming. The feature also helps the prototype water batteries last longer, retaining more than 85% of their capacity after 500 cycles, the researchers' experiments showed. Lead-acid batteries have a low energy density and are used to start petrol or diesel car motors and in large-scale grid energy storage. However, because they contain lead and hazardous acids, they cannot be disposed of and must be recycled at specialist facilities. 4-cloned rhesus monkey. What began in 1996 with Dolly the sheep has now reached Retro the rhesus monkey, and this is actually the first cloned representative of its species to reach adulthood, born in China. On July 16, 2020, the primate was created as part of the so-called somatic cell nuclear transfer procedure. In this process, scientists remove the nucleus of an egg cell and replace it with the nucleus of the animal they wish to replicate. This technique has not only been used to create Dolly, but also cows, mice, pigs, goats, rabbits, and even dogs. Genetic engineering took a leap forward in 2024 with the successful cloning of the first rhesus monkey, named Retro. This achievement, while raising ethical concerns, offers promising possibilities for medical research. Genetically identical monkeys provide a valuable resource for studying diseases and developing treatments, potentially reducing the need for animal testing in the future. However, it also raises important ethical questions about the limits of scientific experimentation. In a state-of-the-art laboratory, researchers peer into microscopes, carefully monitoring the development of cloned embryos. Petri dishes line the countertops, each containing a tiny cell cluster that holds the promise of genetic replication. A rhesus monkey named Retro plays in a nearby enclosure, unaware of the groundbreaking scientific achievement that bears his name. Ethical debates swirl around the cloning experiments as scientists weigh the potential benefits against the ethical implications. Chinese researchers have cloned the first rhesus monkey, a species which is widely used in medical research because its physiology is similar to humans. They say they could speed up drug testing, as genetically identical animals give like-for-like results, providing greater certainty in trials. Previous attempts to clone a rhesus have either not led to births or the offspring have died a few hours later. One animal welfare group has said it is deeply concerned by the development. In mammals, sexual reproduction leads to offspring made up of a mixture of genes from their father and mother. In cloning, techniques are used to create a genetically identical copy of a single animal. The most famous cloned animal, Dolly the sheep, was created in 1996. Scientists reprogram a cell from another sheep to turn them into embryos, which are building block cells that can grow into any part of an organism. These embryos were then implanted into Dolly's surrogate mother. The researchers used 113 embryos, 11 of which were implanted and achieved 2 pregnancies and 1 live birth. They named the monkey Retro after the scientific method called trophoblast replacement, used to produce the animal. 5. HIV vaccine. On the occasion of World AIDS Day on the 1st of December 2024, the International Antiviral, formerly AIDS Society USA, ISUSA, has published new international guidelines for the treatment and prevention of HIV. The updated recommendations were developed by a panel of volunteer medical experts, including DZF scientist Prof. Clara Lehmann of the University Hospital Cologne. They are based on significant advances in antiretroviral therapies and new prevention strategies, such as pre-exposure prophylaxis. The 2024 guidelines highlight the significant progress made in the fight against HIV, while recognizing that there is still much to be done to ensure equitable access to life-saving interventions. Human immunodeficiency virus, HIV, infects over 1 million people each year, and finding an effective way to prevent it has been challenging. Pre-exposure prophylaxis, PrEP, is available for those who may be at risk for HIV through either sexual intercourse or intravenous drug use. However, these treatments have thus far only been available through daily oral medication or a bi-monthly vaccine. This year brought an exciting new breakthrough in the form of an HIV vaccine that only requires 2 doses per year, a far more convenient and potentially more affordable option than current PrEP options. A study published in the New England Journal of Medicine in July 2024 demonstrated that enoxaparin, a vaccine created by American pharmaceutical company Gilead, was completely effective at preventing HIV infections in women. Over 2,000 cisgender female subjects were given the vaccine twice a year for 2 years. Not a single one of them contracted HIV in that time, whereas an equal group of subjects given oral PrEP still showed a 2% infection rate. More promising news came in November, when a second study was released, this time testing enoxaparin on a mixed gender group including cisgender men, transgender men and women, and non-binary individuals across multiple countries. Out of more than 2,000 patients, only 2 contracted HIV, a remarkable 99.9% success rate. The prestigious journal Science named lenacavir its 2024 Breakthrough of the Year, thanks to its groundbreaking approach to preventing one of the most challenging health crises in history. We hope you liked the video. If you did, please give us a like, share, and subscribe to our channel for more videos like this. Don't forget to leave a comment below. We would love to hear from you. Thank you for watching and see you next time.